Hey guys, Mr. Milton here. Today we're going to talk about formulas, or also called literal equations. We're going to talk about solving literal equations. So after today's video, you should be able to solve an equation involving multiple variables. It kind of takes on a new meaning here, but we'll get onto that. Okay, so big question. What's the goal when you're solving an equation? And that goal is to isolate a variable. Okay, we're going to talk about some new types of problems today, literal equations or formulas, however you want to look at that. But we're going to show that the rules kind of will stay the same, no kind of about it. So we're going to solve each of these questions below. It says solve each equation below for x one step at a time. So we have 2x minus 3 equals 15. We're going to try to get x by itself, or isolate x. Our first step should be to add 3 to both sides. So 2x equals 18. Divide by 2. And x will equal 9. Okay, pretty simple there. Alright, looking at the right side. We have ax minus b equals c. Okay, now don't let this confuse you, because we're going to do the same thing. We want to get x by itself. Okay, we go through the same order. We need to make sure that we add and subtract first, outside of b in parentheses. So we're going to add b to both sides. Ax equals. Now on this right side, we have c plus b. We can't add those together and get d or anything. So we're going to just say c plus b. We don't know what they mean, but we know they should be added together. Okay. Now on the left side, we have ax equals c plus b. What's stopping x from being by itself? The answer is a. What's a doing? It's multiplying. So in order to get rid of a, we have to divide. So we divide, and then on the left side, we're left with just x. On the right side, then we have c plus b over a. You might think that's confusing, but if you look at these problems, even though our answers look different, the process is exactly the same. Process does not change at all. Okay, we asked ourselves the same questions on both sides, and actually, a is 2, b is 3, c is 15. Everything exactly the same. Plus 3 plus b. Divided by 2, divided by a. Our answer is x equals 9. The difference is now we could simplify all this, because otherwise we would have to write this as 15 plus 3 divided by 2. But that's 9. There's no way to simplify c plus b divided by a. Okay, let's look at some more problems. It's really important for us to realize what the directions are telling us to do. In this first problem, it says solve each equation for x. Okay, so number one, you might say, oh, we already have something by itself, but they don't want that by itself. They want x by itself. So first problem, what's stopping x from being by itself? 4 and the minus 3. We work with the minus 3 first. Add 3 to both sides. And so we'll have y plus 3 equals 4x. Okay, then we'll divide both sides by 4. And we'll get y plus 3 over 4 equals x. Okay, and I like to put my variable first, so I will. Alright, not too bad. If you feel like you got this, you understand what's happening, go ahead, pause it, try to do it on your own, or just keep me playing it as you go forward to see if we're on the same track or on the same page. Number 2, we have x over m equals 4n. Again, we're trying to get x by itself. So, what's stopping x from being by itself in this problem? It's n. What is n doing? Well, n is multiplying. Or sorry, dividing. So to get rid of it, we have to multiply both sides by m, using inverse operations just like we would in any other problem. So when we do that, we have x equals 4mn. And that's it. Alright, number 3 is tricky because x is in the denominator. Okay, so anytime our answer is in the denominator, if we just try to get it by itself at first, we'll end up with like 1 over x. So my first step is going to be to get x out of the denominator. Again, I'm going to ask myself, well, what's x doing on this side then? X is dividing, so to move it and move it out of the denominator, I'm going to multiply both sides by x. And so that means on my left side I have m equals 4nx. Now, m is by itself, but remember the directions tell us to solve for x. So now I have to say, what's stopping x from being by itself? In this case, it's the 4n. What is 4n doing to x? It's multiplying. Okay, remember when it's right next to each other without addition symbols, it means it's multiplying. So I'm going to divide both sides by 4n. And on the left side, that cuts out the n. Or sorry, on the right side, that cuts out the n and the 4 and leaves just x. So I have x equals m over 4n. And I'll do the same thing on this next problem. Okay, I need to get x by itself. What's stopping it from being by itself? It's 13, this negative 2x. So I'm going to move the 13 first. Subtract 13 from both sides. And remember, we know to subtract because there's no sign in front of here, and so if there's no sign, it's because we all assume it's positive. So 13. So I have negative 2x equals 25 minus 13, which is 12, divided by negative 2. And so then x equals negative 6. And that's our answer. Okay, so hopefully through these problems you see it's really the same thing. You're doing the same process that you would do if I just said solve for x and there was another number here. Okay, get x by itself. The rules don't change. The process is exactly the same. Flip it over to the back, still going with x here. Try to get x by itself with the directions set on the front of the page. Okay. So number 5. It's kind of tricky because you see y here. So some people have the urge to divide by 7, but that is not what we should do here. We're trying to think of what's stopping x from being by itself. It's the 7y or the negative 7y and 3. This negative 7y is not touching it. Okay, it's subtracting. So we can get rid of it by adding. So we have 3x left on the left side, 7y plus 12 on the right side, and then we'll divide both sides by 3. So now I do that, it cancels out my x on the left side. I have x equals 7y plus 12 over 3. Okay. And that's the fine answer there. Okay, you could, if you wanted to, I don't tell you you have to do this, you could divide each of these terms by 3. I know that 12 and 3 simplify. So you could, if you wanted to, write it as 7/3 y plus 4. These are the same thing. Alright. Right side, number 6, we have z equals 2/3 xy. Okay, so there's a fraction. Fraction and variables. Okay, doesn't change what we do though. We still know how to do the same thing. So what's stopping x from being by itself? Well, this 2/3 and this y. What's the 2/3 doing? It's multiplying. So to get rid of it, we have to divide. Remember, when dividing fractions, that means we're multiplying by the reciprocal. So we have on the left side 3/2 z. On the right side, that will give us like 6/6, which simplifies to 1. So that's good. 1xy, we don't have to write the 1. Alright, now what's stopping x from being by itself? It's this y. So we divide by y. Alright, now this looks funky because we have 3/2 z. I'm going to rewrite this. Okay, and so I'll write 3z, okay, because 3 times z, I'm keeping that at the top. And then the denominator, I'll have 2y, because I'm dividing by y, and the 2 is already in the denominator. On the right side, I have x. So x equals 3z over 2y. And that's our full answer. Okay, the worst part about these literal equations for most people is that the answer isn't just like 7, 6, 14, negative 32. Okay, the answers aren't able to be simplified as easily. Okay, you might say, well, when will this ever help me? Why would I ever need to know how to do these literal equations? Okay, well, in real life, some of these things could happen when you're converting from one thing to the next, or if you're using scaling or ratios or something like that, where you have a lot of variables and you're changing what you're going to keep the same. But let's go through some story problems as close to real life as we'll have in math class, but the real reason for math. So, on her trip to Europe, Jane was told that the temperature in a certain area was on average 30 degrees Celsius during the time where she would be there. What clothing should Jane pack? So we're going to solve for F here. And so we'll do that. I'll get rid of the 5/9 first. So I'm going to multiply both sides by 5/9 or 9/5. Rewrite this 5/9 F minus 32. I'm going to multiply both sides by 9/5 because 5/9 is multiplying, and so in order to get rid of it, we have to divide. And remember, with fractions, when you divide, that means you are multiplying by its reciprocal. So on the right side, it cancels out. I'm left with 9/5 C, F minus 32. And to get F all the way by itself, I need to add 32 to both sides. So I'm going to write that over here. So I have 9/5 C plus 32. And that's what F equals. And so now I'm going to use the formula to find out what kind of clothes Jane should pack for her trip to Europe. So, if C is 30, then I can say, well, F will equal 9/5 of 30 plus 32. 30 times 9 is 270. 270 divided by 5 plus 32. 270 divided by 5 is 54 plus 32. That means it will be 86 degrees. Okay, so Jane should pack some warm clothes. Or warm weather clothes. Alright. Okay, so hopefully you're able to use literal equations to solve literal equations or equations with more than one variable, and also to use them to apply them to real life situations. See ya.